Okay, we are trying to solve this system. It's a system of three equations and three unknowns. The way I suggest you do these is you number the equations 1, 2, and 3 with circled numbers. Now, the first equation is x minus 2y plus z equals 4. Second equation, negative 3x plus 5y minus z equals negative 9. Third equation, 4x plus 2y plus 4z equals 6. In order to eliminate x, because the first thing we want to do is want to eliminate x from two of the equations by adding multiples of rows to rows. So what I want to do is, if I multiply everything in the first equation by 3, well, then I'm going to have a 3x in the first equation and a negative 3x in the second, okay? And when I add them, the x's will go away. Now we have to write this out carefully, coherently. So I'm going to write this out way to the left here, okay? I'm going to write out again equation, well, 3 times equation 1. Now, I'm going to ask everybody to write out 3 times this first equation. So make sure you understand what I mean by 3 times the equation. So just write exactly what I wrote. 3 times equation 1, and then to the right of that, write the equation. Okay, so you've written 3x minus 6y plus 3z equals 12. One person read the z as a 2, but we'll just make sure we see that that's a z. And that was easy to correct. So now we want to add that to the second equation. So what we're doing here is 3 times equation 1 plus equation 2. Start with 3 times equation 1, write equation 2. Have you got that? Okay, you should have, everybody's got it, negative 3x plus 5y minus z equals negative 9. Okay, then we do 3 times equation 1 plus equation 2. We're going to add the x's, we're going to add the y's, we're going to add the z's, we're going to keep the equal sign, and we're going to add the numbers. So go ahead and do that. Okay, now you should see why we did what we did. We've eliminated x between the two equations. 3x minus 3x gives us 0. Negative 6y plus 5y is negative y. 3z minus z is plus 2z. And 12 minus 9 is 3. Now you've got 0 here. And I've explained it's important to have these lined up so you can see what you've done. Some people just didn't bother writing the x and had negative y plus 2z equals 3, and it was over this way. We want to keep everything lined up, okay? It's easier. And if you make a mistake, it's easier to spot it. Okay, so what we're going to do with this system, we're still going to write equation 1. But instead of equation 2, we want to eliminate the x in the equation 2, which we've done. We've done that by multiplying 3 times equation 1 and adding it to equation 2. That's what we've done over here. We don't do that underneath. We keep everything lined up, and we do the side calculations off to the side. Now, you can do it a different way if you want. And if you get it right, it's okay. But I think you're going to see it much better if you do it the way I'm saying. Okay, so we get no x here, so we don't really have to write 0. But we're going to get negative y plus 2z equals 3. So the reason we did this over here is so we could have no x at the beginning of this equation. Okay, then we want to write out the whole system. But we're going to do negative 4 times equation 1 added to equation 3. Okay, so we do that over to the side. Do it the same way you did the first one. And you see that if we do negative 4 times equation 1, we'll have a negative 4x. And that's going to be added to the 4x, which will give us, again, no x in this equation. Okay, looks pretty good. Want to be careful about the labeling. You want to do negative 4 times equation 1 plus equation 3. So I'm just going to write that as kind of a heading, negative 4 times equation 1 plus equation 3. Then I'm going to write negative 4 times equation 1. That's going to be 4 times x minus 4 times 2y is negative 8y. And 4 times z is 4z. And 4 times 4 is 16. Okay, so there's my negative 4 times equation 1, but I need equation 3, and I'm going to label that right below equation, negative 4 times equation 1. And I copy equation 3, 4x plus 2y plus 4z equals 6. Now, I made at least 2 mistakes when I multiplied negative 4 times equation 1, because I just multiplied 4 times equation 1. Okay, so my signs are all wrong. Negative 4 times x is negative 4x, and negative 4 times negative 2y is plus 8y, and negative 4 times z is negative 4z, and negative 4 times 4 is negative 16. And so now I've got it right. I think you had it right at first. Okay. So what do we get when we add these? We label that. Again, negative 4 times equation 1. Comes to equation 3. Okay, let's see again. Negative 4x and 4x gives us 0. 8y and 2y gives us 10y. Negative 4z and 4z gives us 0. So I'm going to write my zeros in. But that really, we don't have to write the zeros in. We write it over here. We're just going to write 10y equals negative 10. Now I'm going to do something that seems a little bit unnecessary. I didn't plan this so that the z's would cancel out, okay? So I'm going to write now. I'm going to write the system, but I'm going to take, then I'm going to, the first equation is going to be the previous equation 1. So I write a circle 1. That's x minus 2y plus z equals 4. I'm going to write equation 3 from before. That's the 10y equals negative 1. Now I'm going to write my previous equation 2, which is negative y plus 2z equals negative 10. Then I'm going to write the system. I'm going to write the system I get when I multiply equation 2 from this step. Now this is numbered 3 because it was equation 3 previously, but now this is equation, when we're down in this step, this is equation 1, this is 2, this is 3, even though it's labeled differently, okay? So we take equation 2 from before, the second equation, 10y equals negative 1, it's negative 10, and it's y plus 2z equals 3. I didn't write that down correctly. Okay. So go ahead and write out this step, and then write out what you would get in this step. Okay, so got this step nicely. I think these things were labeled. If they weren't, make sure they were. You get this. And if you divide equation 3 by 10, well, that's easy. You can do that in your head. You got 10y equals negative 10. You're going to get y equals negative 1. And then your third equation is negative y plus 2z equals 3. Now, at this stage, we're going to come over here and we're going to do, well, what would you do to eliminate y between these two equations? What would you do to equation 2 and equation 3 to eliminate y? Well, you would just add them, wouldn't you? If you add this equation to this equation, the y's go away. Okay? So what we're going to do is we're going to rewrite the system again. We're going to write the first equation, x minus 2y plus z equals 4. We're going to write the second equation, y equals -1, and we're going to write equation 2 plus equation 3 is the third equation. So what do you get when you do that? Okay, now that one little error, somebody didn't have a negative on that one, but you don't really need to write these two out separately. You probably don't need to, but if you do, don't hesitate to do it. When in doubt, write it out in a scratch area of the paper, like this area here where we just scratch things out so everything would look nice over here. All right. If we add the second equation to the third equation, though, we can see that we're going to have y and negative y, which gives us 0. We don't have any z here, so we have 0z. Add that to 2z, and you get 2z. And then on the right-hand side, you get -1 and 3, which is 2. Now we're going to write them out again. And we're going to divide our third equation here by 2. Which equation 3. Now you still got 4 here. Okay, that should be a -1.
I was thinking one about double my equation 2.
Oh, wait, okay, you got it up here. But when you got this equation by adding equation 2 to equation 3, you didn't use a -1 when you did that. Let's see. Okay. So that comes down to this equation, and that should have been -1, right? So if you add this equation to this equation, you're going to get 2, not 4.
You got 2, yeah, so you're
Okay. So that's got to be 2. So you got z equals 2. Now you write it again, you're going to have z equals 2, right? Okay. there's some dead space in the video because I was recording when I didn't know I was recording. I messed up somehow. Okay, well, all we're doing here is we're writing down equation 1 and equation 2, like it says. And there's equation 1 from above, equation 2 from above, equation 3 above is 2z equals 2. If we divide everything there by 2, we get z equals 1. Now, somebody had a little glitch. They forgot the negative in front of the 1. They got a 4 here instead of a 2 in the previous step, but that was easy to fix. So here we have it. So here are the same equations. Okay, and we're almost done. Now, we're going to plug z equals 1 and y equals 1 into equation 1. For the equation x minus 2y plus z equals 4 becomes x minus 2 times negative 1 plus 1 equals 4. We've replaced y by negative 1. We've replaced z by 1. So x plus 2 plus 1 equals 4, which gives us x plus 3 equals 4. We can subtract negative 3 from both sides, and we get x equals 1. Okay, so once you know z, usually once you know z, you can plug it into the second equation. But once you know z is 1, you can plug that into the second equation, but the second equation doesn't have a z in it. It's already got y, okay? Now, usually there's going to be a z here. You'd have to plug 1 in for that z and solve for y, but that's easy. At that point, you have values for y and z that you can plug into equation 1 and find out what x is. Then you can plug those numbers into all 3 of the original equations and see that they satisfy the equation. Okay? Okay. Now, the main thing is figuring out what you need to do at each step. You want to follow the steps in order. Now, let's just look at how this system evolved. Okay, we started by eliminating all the x's, which gave us blanks down below x. Okay. Then we eliminated y between the last 2 equations. We got this equation. Okay. So the main steps we first got zeros down below the x. Then we got zeros down below the y. That was this system here. Then we solved the third equation for z. Okay, so we have this system. Then we substituted and we got all the results. Okay. Now, can you write the original system, which you can't see because of the way I've got things? Let's get the original system over here so everybody can see it. Now, can we write the original system as an augmented matrix? Okay, fill in the numbers in the augmented matrix. Now, on the homework, I noticed everybody did well. If they were given the augmented matrix, they could write the system. Okay? So just make sure you can write the augmented matrix if you're given the system. Okay, the original system, which I no longer have up there, but let's go ahead and get it so we can see it. Okay, here's the original system. When you write the augmented matrix, we just write the coefficients of x, y, and z. And then to the right of the dotted line, we write the number to the right of the equal sign. So for the first equation, we'd write 1, -2, 1, 4, which stands for 1x minus 2y plus 1z equals 4. Then we write the other two equations similarly. -3x plus 5y minus z equals -9 comes -3, 5, -1, -9. Then the third equation, 4x plus 2y plus 4z equals 6, becomes 4, 2, 4, 6. Okay, so what are we going to do next? Well, we're going to follow the same steps that we followed previously. We're going to write the augmented matrix again. But what we're going to do is we're going to take 3 times the first row and add it to the second row, which is just like what we did when we added 3 times the first equation to the second equation. So we're doing 3 times row 1 plus row 2. Oh, sorry. In the first row, we're writing row 1. We're not going to change row 1. So the first row is going to be row 1. Second row is going to be 3 times row 1 plus row 2. And the third row is going to be -4 times row 1 plus row 2. Now, you need to calculate that. You're probably going to go off to the side someplace and scratch it out the way we did here. Now, we're very short on time, so I can't do that on every step, but I'll do that for -3 times row 1 plus row 2. -3 times row 1 would be the row. 3 times 1 is 3. 3 times -2 is -6. 3 times 1 is 3, and 3 times 4 is 12. And then row 2 is -3, 5, -1, -9. And we just add the numbers. 3 and -3 gives us 0. -6 and 5 gives us -1. 3 and -1 gives us 2. 12 minus 9 is 3. Okay, so what are we going to write down? In the second matrix, we're going to write down row 1. 1, -2, 1, 1, 4. -3 times row 1 plus row 2, that's what we have here. That's 0, and we've got to write the 0. We're not going to put a blank in there, we're going to put a 0 in. Okay. Then we do -4 times row 1 plus row 2. And I'm not going to write that out over here, but you should write it out somewhere. But not in the column. It's going to have one matrix after another. You're going to get 0, 10, 0, -10. And what we're going to do is this row here that has a Y in it, but no Z or X, we're going to make that our second row. So we're going to switch the third row and the second row of our second matrix, and we're going to get a matrix that has first row 1, -2, 1, 4. Second row is going to be the third row of our previous matrix. That's our 0, 10, 0, -10. And the third row is going to be the second row of our original matrix, our last matrix, which is -1, 2, 3. Then we're going to keep rows 1 and 3 the same as they were, but we're going to do row 2 divided by 10. We're going to have 1, -2, 1, 4, 0, 1, 0, -1, 0, -1, 2, 3. Now you should repeat these steps. We're out of time. We're a little over time, so I'm going to have to finish off. I didn't want to rush things when I was having people work everything out. Okay. This matrix then is going to be row 1, row 2, and row 2 plus row 3. Okay, row 1 is still 1, -2, 1, 4. Row 2 is still now 0, 1, 0, -1. We're going to leave that the way it is because that's the row that tells us that Y equals -1. And then our third row, we add the second row of the previous matrix to the third row and replace the third row. We're going to get 0, 0, 2, 2. And then finally, we get the matrix. Okay, we're just going to divide that last row by 2. We're going to have the first row still 1, -2, 1, 4. Second row is still going to be 0, 1, 0, -1. When I copied down the third row from before, it was 0, -1, 2, 3, 2 times. No, never mind. I'm dividing row 3 by 2. It doesn't change this. 0, 0, 2, 2 gives me 0, 0, 1, 1. Now, this augmented matrix translates into this system. One, -2, 1, 4 is x minus 2y plus z equals 4. 0, 1, 0, -1 is y equals -1. 0, 0, 1, 1 is z equals 1. So we translate this back into this. Plug z equals 1, y equals 1 into the first equation. You get the same solution we got before. What's going on here is we just don't write out the x's, y's, z's, and the equal signs. but we do exactly the same operations, and look at how it evolves. We start here, and now we've got a 1 at the upper left and zeros below it. That's what we want. And then we want a 1 in the second column of the second row and 0 below that. Once we have that, we can get a 1 in the third column of the third row, and we have 1, 1, 1 on the diagonal elements of the matrix, okay? And that translates into a system that we can solve by back substitution. So we want to get good at both of those processes. I do recommend you write it out in the form that I say, because you'll learn it faster, keep it more organized. Pretty soon, you'll see where everything goes and you'll understand what to do with every step. Okay. Okay, very good. So good luck with that. We'll try to do some review next time, give you an idea what to expect for the final and so forth.